Okay, so we discussed about if else conditions. Basically, how can you write if else conditions and stuff like that. Uh, what are expressions, how to evaluate expressions, how to work with expressions, etc. Now, the next thing we discuss about switch case. Sorry, go mod init. I just give demo code main.go. Here you go, package main, function main. So switch case is like in any C language, C language family. Traditionally, how you write switch case. For example, I give num is, for example, 4. Okay, this is an integer. If you want specifically where num is uint8, which is 4, you can assign a number. So what we do, switch num. That means uh, we want to ultimately create a equal to operator for each and every case. Whenever you write like this, it's a basic switch. We have case 1, that means num is 1. Let's say print line, uh, for example, Sunday. So I have 2, which is called Monday. Let me write it in capital letter. And then I have 3, Tuesday, 4, Wednesday, 5, Thursday, Friday, and Saturday, which is got 6, and then just got 7. And there is a default case. That means if this variable not fall under any case, it goes to default. This is a very straightforward switch case statement you see in the C language and some family. There is a difference between switch case statement, switch case of C family languages along with the difference with Go. There is a difference. Generally, break is there for every case. Actually, you have to write a break. If you don't write a break, what happens? For example, here num equal to 4. We put switch num. It goes to fourth case because 4 is satisfied. If you don't put a break here, I'm not saying in Go, but in other programming languages, if you don't put break here, without looking at the case, it executes line number 14. It also executes line number 16, case 5, line number 17, 18, sorry, line number 20, and also line number 22. If break is not there, once one of the cases is satisfied, thereafter, then after all the body of the cases are executed until there is a break. Okay, that is how in C, C++, Java, C Sharp, and these programming languages. But in Go, break is automatically implemented. You don't need to specially put a break. You don't need to go and put a break. Break is already there, automatically there. You don't need a break basically. Switch is designed in such a way that you don't need to put a break. Okay, switch num if actually what happens if num equal to 1, if num equal to 2, if num equal to 3, like that. Basically, this is how it works. So this is a basic. If num belongs to none of the cases, it goes to the default one. That is how it works. That means it has to print Wednesday. Wednesday. Let's say I give as 8, go run, it goes no day because 8 doesn't belong to any of the cases. It falls into default. This is a basic switch statement. There are various variations for switch statement, switch cases in Go. This is a basic switch statement. Let's go to the another example. Let me do it in another example. Copy or 9 switch case with the 10 switch case. It's also kind of or. I go to the 10th example. Let's say char is, char is room. I give as room equal to, for example, oh, I want to check what the char is. Is it a, whether the char is a vowel or a consonant or a special character, or I just go ahead with the vowel or consonant. I can check where case, it's a, comma e, comma I, comma o, comma u, comma capital A, capital E, capital I, capital O, capital U. You can write like this. It works like a OR condition, though there is no condition that we write, but it works like a OR condition. Let's say you want something like, so I put it as print line string of char because is a vowel. It's a vowel. Okay. So if you want to write for consonants, yeah, you can write, but it's quite difficult because B, you have to give C, D, E, F, G, H, J, K, L, M, N, P, Q, R, S, T, U, sorry, T, U, V, W, X, Y, and then Z. Similarly, you can put it for capital letters as well. So what you can do here is, okay, you can put it as capital letters as well. Let it be very simple one. Later on, we will see Y, X, W, V, T, S, R, Q, P, N, M, L. So if any of these characters, then it is a consonant. Otherwise, it's a string character is a special characters. So this is kind of a OR condition you can perform on if else. Go run. You see that O is a vowel. Let's say I put as capital O just to check. Still O is a vowel. I put it as Z. Sorry, I didn't save. Z is a consonant. I put a special character. It's a special character. This is also this works like a OR condition. So char equal to any one of them, actually char equal to any of one of them. Char equal to A, it automatically invokes like char equal to A, something like or char equal to E or char equal to I, something like that. It works. Any one of them is done, then it works. Again, it is also char equal to. Char equal to. This works a direct basic switch which tells char equal to. Right. Let's go to another variation of the switch statement. Switch case condition. Another example. Code main.go. We go here. Let's say I give a number. Let's say I give a number. Let's say where num is equal to 100. Let's say 30. So you can also create a variable like this. All right. Switch. This is called empty switch. When to write empty switches? When cases or conditions, like if like conditions, then the switch should be empty switch. Here cases will be conditions. I write condition with case. You usually don't find this kind of variation in many programming languages. That means case num, for example, a simple thing, num modulus 2 equal to 0, say print line num is even number, default print line num is odd number. You give a number, you can simply evaluate. So this is kind of a condition that you write. This is a condition. I will show you other condition as well. This is a condition. Let's say go run, that is even number. I give 31. 31 is an odd number. This is an even number. It's a simple thing. Another example we give, we are more conditions if you want, right? So switch again, number equal to maybe 50. I give same variable I'm using. Again reassigning, mutating a variable, switch number. Sorry, you cannot give number if you want to write condition. If you want to write any condition with case, you cannot give number. Let's say case number is greater than or equal to 0 and number is less than 50. If you want, you can write block statements as well. You can also put, not required. If you want, you can put. print line. For example, number is between 0 and 50. I'm not doing anything, just writing a simple condition. You can also write condition within switch statement. That's what I want to say. Number is equal to 50. Number is greater than or equal to 50. And number is less than 100. Print line. Number is between 50 and 100. Like that you can write based on whatever the case is. Default print line number is greater than or equal to 100. Let's say what if the number is less than 0, you can write a case. Case number is less than 0. Like this you can write conditions actually basically within switch. This is also called empty switch. So when do you write empty switch? If you want switch, you can also write if else condition. There is no problem at all. But empty switch looks more case by case. You can have a look at it. This is called empty switch. Okay, this is called empty switch. So 31 is an odd number, and then 50 is between 50 and 100. Between 50 and 100. Like this, you can write a condition with the switch. These are all patterns basically. You can write a condition. Okay, here also you can write a condition. See, this condition could be of any big condition. Simple thing. I will write add more conditions. For example, here, however, it is true here and true or untrue and true or false and true. If you look at it, there is no, it doesn't make any sense. But still, you can say if this is true, untrue is true, untrue is true, and sorry, true and false, true or false, which is called true and true, automatically the whole thing will become true, just mimicking something, because the whole thing becomes true. Okay, because the operator precedence or is this has more than this, so wherever and is there, it is evaluated first. Let's say if you want, you can also put like this. There is no meaning in this logic. I am just simply writing the logic. How it is evaluated? 50 is greater than 50. Okay. If you look at it, this is true and true because 50 is less than or equal to 100, and true and true or false, which is called true and true. Okay. True into true is true, and true into true is true and true. So true and true is true and true, which is called true. So the final result is true. For example, if I put final result as false, still it came like this. I don't know. Still it is evaluated at true. 50 is greater than or equal to 100. I put false. So how it is evaluated as false? If you just take the full condition, Okay, and then print this condition. You understand? Are you getting true or false? It's getting false. Oh, okay. It came here. Sorry. It came here. It is true. Because it came false. Because we put a false here. 50 is greater than or equal to 100. It did not go into this one. So there is no meaning in this, but trying to show that you can write any big condition as long as the condition is makes sense. You cannot go and put arithmetic operator here and say that, hey, my condition is not working, because conditions are generally true or falses. Let's say and 100 equal to 50 into 2. This is an arithmetic operation and this is a comparison operation. This arithmetic operation is evaluated, expression is evaluated and then does with the comparison. As long as comparison operator is there, then it comes as true or false. Okay, logical operations, comparison operations always give true or false. But arithmetic operations don't give true or false. Okay, arithmetic operations perform arithmetic operations on numbers, not on another variables. Just giving you some example. Remember that this is to show that, yeah, you can write an expression, you can write a condition that is so big it doesn't make care. It ultimately look for the condition is true or false. The ultimate result should be true or false. You can write any big condition and do that. Okay, this is how you can write conditions in if else. The last but very important if else condition is called switch type. Switch case for the type switch. We call it as a type switch. So copy R11 switch case 11. So switch case type, I give the name. So I give it into this particular thing. I'm removing everything over here. You know, we have something called var anyone as any. You know, if you know about any is a special type which can hold any kind of data. Basically, any can hold any kind of data. We already discussed about any in example 5 and 6, most probably third or fourth or fifth session. Any can hold any kind of data. That means you can give any kind of value to any. Right. There is something called type switch. What type switch does is at runtime, what this any belongs to, you want to perform something based on any. Generally, we write type switch. So which is called type switch. How do you write type switch? There is a special syntax for type switch. Switch any dot type. Any one dot type. If you want to give any variable, okay, any one dot type. Any one dot, it returns the type of the variable. It returns the variable of a specific type. Remember that this variable is of a specific type. Okay, this variable cannot work on or condition like this. It doesn't work like this. Remember that it doesn't work like this. It works for one variable. Let's say I give a value called 100. So case int, it's a type. It returns a type. This is a type. It's a special switch, type switch. We call it as a type switch. It is specially designed to work with any type. or empty interface, anything, either any or empty interface, anything is fine. If you give empty interface also, it is the same, because empty interface is nothing but alias of any. You can either use empty interface or any. Case any, that means if the type of any is integer, print line v is int. Just printing, I'm not doing anything. Float 64, v is float 64. Let's say case bool, print line v is boolean. Case string, print line v is string type, boolean type, float 64 type, bool type actually, int type. If it doesn't falls under any of the cases, then you have default. It is a separate type. So if you want to really work with all the types, you have to write the types in case statement. Then only you can work with all the types. Okay. Without doing this, you cannot. Initially, there were no generics in Go language, so maximum logic people write is using any or empty interface. So 100 is int type. Let's say I give 100.23, automatically 100 becomes float 64. It's taking some value because it's not formatted. Let's say I give as boolean true, 100 is bool type. I give hello world, 100 becomes string type. Let's say I give where num is uint 8 equal to 100, equal to 100. I put num. Here the any type belongs to uint 8. We did not write, we are not checking with uint 8. Uint 8 is not int. Any type, a type is a different, each type is different in Go. But you cannot put like this. You cannot put like this because this doesn't work. If you can put actually, but it's quite complicated stuff. I'll tell you why it is. Because even while performing an operation, if you need a type, you need to typecast. It doesn't work basically. Okay, here I put int and uint 8. Let's see. Is int type, because here I put int type, but it is uint 8. Okay, see, you see that the value of v, if you really look at the value of v, earlier it has given as 100, but now the value of v is given as some kind of a pointer. Let's say I'll do one thing, fmt dot print line I put num, which is of int. Again, I got 100 is int type, but here I got, but actually 100 is not an int type, 100 is a type of uint 8. Okay, right. 100 is of type uint 8. Let's say I want to type check uint 8, uint 16, uint 32, uint 64, int 8, int 32, int 64, uint. Okay, V is int type. Basically, it is not int type. V is a type, and then V is you have to use reflect package type of in order to know the type of V. V is uint type. Let's say I give instead of uint, I give uint 64 and give a big number. Uint 64 type. So type annotations, whatever. 1 minute. Type annotations. So sorry, switch type you can use like this. If you want to see, basically one thing I want to tell, like this, you have to check actually each and every type of a variable. Okay, at runtime, all the types should be written. Let's go to another example. I don't want to put everything in this example. I want to put multiple examples. So CPR 12 and then 12, but I put it as 13 as another example. Go to main.go and here. What I do here is I take two variables, any two of 100. I take two variables, any one and any two. For now, I want to perform some arithmetic operation. Ultimately, what I would like to do is, I'll tell you what I would like to do is, I take two variables, I want to perform arithmetic operation, let's say where sum is float 64 equal to any 1 plus any 2. This is the operation I want to perform. This is called as zero value. This is called as type inference zero value. Zero value means it's not about zero, zero type or zero value. Any type, the zero value will be it's the default value. Let's say what is the zero value of str1? The zero value of str1 is empty string. The zero value of boolean is false. The default value or zero value, generally this is called as a zero value. Fine. I want to perform arithmetic operation. Something is you perform arithmetic operations on numbers. If it is plus operator, maximum you can do concatenation on strings. But you cannot perform arithmetic operations on booleans. You cannot perform arithmetic operations other than numbers. So if you want to perform any arithmetic operation, should be very clear that the arithmetic operation has to be performed on numbers. So since my switch type can perform arithmetic operations on numbers, on float decimal values and floats on normal real numbers, what I can use is I can use float. If you use float as the sum, it can add even normal numbers or numbers with a decimal values. So what I do, switch, which is called a type switch, any one dot type, it's a type switch. Case of It could be int, uint, uint8, uint16, uint32, uint64, int8, int32, int64, float32, float64, any one of them. What I do, sum plus equal to v, but v could be mismatched types. It is saying that v is of any. So this is a problem actually. You cannot write white set float 64. I am trying to do with one. This also you cannot do. The reason is sum plus is 64 and then the resultant value cannot convert v of type to float 64, need the type. To print the value there is no problem, but if you want to perform any proper arithmetic operation you cannot do exactly this way. You need to know the type and then from the type you have to convert to that. So you should always do the operation on each and every type. This works. And then you can put case by case. Int 8, int 16, 32, 64, 8, 16, 32, 64, float 32, float 64, int. So int 8, int 16, int 32, int 64, uint 8, uint 32, int 16, 32, uint 16, uint 32, uint 64, normal uint, float 32, float 64. Other than these types, any other type. So everything, this one you don't need to convert since it is a float 64. I don't think you have to convert because the left side value is float 64, right side value is also float 64. You don't need to do. Other than this, the default is sum plus equal to 0. I just put 0. If you want, you can write a error as well. This is how you can put as anyone. Similarly, you have to do for any two as well. Simple thing is I change it here as any two. So and then you put fmt dot println printf sum equal to percentage f comma sum. So this is how you have to do. This is how you have to do, because you have to typecast, otherwise you get the value of v. Like less previous example, here you are not typecasting, you are just printing the value. Okay, if you're not printing the value, you are performing any arithmetic operation. Then there is a problem. It cannot understand at runtime with a single statement. Here you are just printing the value, there is no problem. Type assertion you don't need to do if you put a case. So what I'm doing, what I did, I take any or anyone and any2 as type any. I give two types of values. One is called num int 64 and another one is called int. Let me give the boolean number, sorry, float number. It's a float 64 and then this is the int 64, uint 64. I take the sum of which is of float 64, and if any one dot type, if any, it belongs to any of the number types. Here any one is what? A number which is of uint 64. It comes to uint 64 and then it performs sum. This value is added to sum because add sum is already 0. Now it is added, the value is 1000, this number. Let me give the small number. It's 1000 is added to sum, and then you go to another case, switch case. Now it is a float 34, float 64, sorry, it goes to float 64, and 1000 plus 1000 dot something, 1000 dot 12312, then 20123 is come as 2000. I'll put 3 decimal 123, 20123. This is how it comes. So this is the importance of type switch. Type switch is heavily used on whenever there is a type called any. Okay, and then whenever you are performing normal operations, there is no problem. Specifically arithmetic operations, you have to write individual types cases for each and every type. It looks pretty redundant code, but yes, you have to write like that. Let's say I create a new type over here, type integer equal to int, where num1 for example is of integer of some value. Now I give num comma num1. Because integer, the underlining type is also for integer is int. The underlining type of integer is int. There is no problem. It goes to that particular underline type and then finds something. It goes to int, integer is int. It treat this integer 2000 as an int and then it perform the addition operation. You don't need to really worry about if there is any this kind of type. These things are taken care. Basically these things are taken care. uh, we don't need to worry about how to take care of these things. Okay, this is how type switch with the switch type switch, call it as type switch. This is how you can work with the type switch. Okay, the next thing is the last example in switch case. Switch case, okay, we have a switch case statement, break. There is something which we can do with the break. uh, you know, whenever there is a break, whatever you want to remove the break, you know, there is something called, there is a break statement. In other languages, if you want to remove the break, what kind of effect that you expect in order to remove the break? Okay. Similarly, there is certain things are there in Go. So in which are the programming languages, you want to remove the break. Here we call it as a fall through kind of a statement. It's called fall through whenever you remove the break in other languages, because not break is not you don't need to put a break. But in other languages, why do you remove the break? Similar thing, if you want to perform in Go, package main, function main. Let's say I have a number, but it's very dangerous operation because it has got false negative impact if you properly don't use it. Let's say I have a number which is called 8. I put switch case, switch, empty switch, case num modulus 8 equal to 0, print line num is divisible by 8. Similarly, I have case num is num modulus 4 equal to 0, print line num is divisible by 4. Similarly, case num modulus 2 equal to 0, print line num is divisible by 2. If you look at this statement, num modulus 8, num modulus 4, num modulus 2, but actually the number something called 8 is divisible by both 8, 4 and 2. But when you run it, it is only you can only get that 8 is divisible by 8 is divisible by 8, but you don't get the answer as 8 is divisible by 4. But a similar example, if you run in other programming language with a switch, you get it as 8 is divisible by 8, 4 and 2 because by avoiding break statement. Wherever in other languages that you avoid break, you want the similar effect in Go. Instead of avoiding break, because break is automatically invoked, you have to put a statement called fall through. What you are telling is num is divisible by 8, then fall through the next body of the statement. That means it doesn't go and check the case, it checks only the body. It falls through the body of the other case. Let's say num is divisible by 8. This case is true. Since it checks fall through, it doesn't check here. It directly comes line number 11 and 12. When you say fall through, it doesn't check the case. It just go to line number 14. Because case statement in switch case is only checked once. You cannot write the case switch case that it checks the case multiple times. Okay. One thing is case, only one case is what do you say? One case condition is evaluated. Want the same effect? What if break is removed in other programming languages? Have to include fall through in Go. Fall through. in Golang, go switch. But there is fall through is a, however, fall through has a, fall through can also give false negative. If when you don't write the order, when you don't write the order of proper cases. Okay, this is fall through success. This is a correct successful fall through. But the same thing, if I write in another way, false negative fall through. The same statement. That's why I said that you have to be very clear about fall through. Let's say number is divisible by 2, number is divisible by 4, and number is divisible by 8. I give 8 here, I give 4 here, and then I give 2 here. This is the thing that you do. Then what happens is I give a value called number equal to 6. The problem here is 6 is divisible by 2. Since there is fall through, it doesn't check the case. Case is only checked once in the entire switch case. Since they put fall through, since there is fall through, whether the next case is satisfied or not, the statements are executed. That means it goes here and then it shows this. Since it says fall through, it doesn't check the case, these statements are executed. So fall through never, in switch case is evaluated, the condition is checked only once. Okay, so you have to be very careful the order of cases whenever you gonna use fall through. If you look at this second example, you understand. When the value is 8, it is divisible by 8, 4 and 2. But when the value is 6, it said that 6 is divisible by 2, 6 is divisible by 4 and 6 is divisible by 8. The reason is the order is given as wrong. So fall through doesn't know all these things. The job of fall through is just a fall to the next body of the case, not the exact condition that it has to check case condition. It just fall through the body of the case. Okay, it just falls to the body of the case. It doesn't check the actual condition, case condition. I hope you understand. Fall through is very dangerous operation if you don't properly use it. You have to be very careful whenever you are using fall through. But here, let's say I give 2. Since 2 is at the last and then there is nothing to fall through. 2 is divisible by 2. Let's say I give 4. 4 is divisible by 4 and 4 is divisible by 2. Let's say I give 6. Since order nothing, no case is executed, 6 is divisible only by 2. But since you in the fall through, it's not a successful fall through. False negative fall through. Okay, I think I wrote this one. In a false negative fall through, since failure and false negative fall through, this is the problem. So very careful whenever you are using fall through. Okay, this is what, when you go through all the keywords that we had gone through, So we had gone through case, default, and also const, func, import, package, and then where, come in order. And we have if, we also did else, we have switch statement. These are the things that we had gone through: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. If you go through built-in functions, we also checked print line, print, and print line statement, two built-in functions. There are around, out of 10 out of 25, here 2 out of 18. There are 18 built-in functions, and then there are 25 keywords. Yeah, we have actually 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have also fall through. So we had gone through 11 out of 25 keywords. Okay. So this is today's session. We will connect tomorrow and then see what all other things we can discuss in tomorrow's session. Okay. Thank you.
Thank you.
Mm.